Happy prototyping, everyone! The project for this video is a calculator repair. The display of my Voyage 200 broke down, so let's repair it. I tried to resolder all pins of the LCD drivers, but it did not help. So I decided to replace the display completely. To make this possible, we first have to study the display signals. Luckily, we can find the display driver datasheet online and study them. The next step is to tap all necessary signals to analyze them. The display driver chips have small bin spacings, so I use a microscope to check every solder joint. This is important to don't overlook some short circuits. Next, we connect the signals to a logic analyzer. Now we can see if the signals corresponds to the signals in the datasheet. This is important because there are often a lot of possible configuration to drive a chip. Later on, this information will be very useful. Next up is the preparation of the new display. I decided to use a display built for Arduino because I already had it on my shelf for future projects. It took me some time to get it running because there was nearly no documentation available for this specific type of display. I also tried to change the settings to grayscale because I only want to use black and white, but it did not work. Maybe some factory settings from the supplier disabled this option. All in all, the display looks promising and will be up to the task. The best property is that it only needs 8 data bits, which is not usual for this kind of displays. Next, we start building the electronics for streaming the display data from the Voyage to the new display. My first idea was to use an FPGA for that, but there is not enough space inside the Voyage. Additionally, a FPGA needs a lot of different supply rails, which we don't have. So it's better to use a simple microprocessor. The clock speed of the display data from the Voyage is around 1 MHz. This is really high for a regular microprocessor. I was looking in my shelf and found a PIC32MX. The PIC32 has a dedicated DMA controller. A DMA controller can interrupt triggered transfer data from one memory location to another. This is perfectly usable to transfer the display data from the Voyage to a memory buffer triggered by the display clock. So we don't have to use the CPU to collect display data, and therefore don't worry too much about timing. Nevertheless, if the DMA approach is not working, the PIC32 is running around 40 MHz, and therefore it should be possible anyway. To program the PIC32, I use my PICkit3. It is a cheap entry-level programmer and debugger for a lot of microchip devices. I officially hate it. I should buy a more expensive one. It took me hours to find the problem why the PICkit did not program my PIC32. By the way, the time lapses are speeded up by a factor of 150. First, I was thinking I had a bad connection. Then I was thinking the PIC32 died maybe on static discharge. Nevertheless, none of that was true. It was the USB connection. I don't know exactly what was wrong, but when I use another USB port, the problem was gone and programming was possible without any problem. But I already replaced the PIC32, so I had to rebuild the electronic again. So it starts to get very frustrating. The PICkit3 is known to be buggy, but I did not have this kind of problems before. Mainly, the PICkit3 has a problem when you draw too much current during programming. So sometimes trust yourself more than the tools you use. This could have saved me some time. Next, we try to control the new display with the PIC32. Also, the new display did not work in the beginning. In the debugging process, I killed my two displays I had at home, so I had to order new ones. This delayed the project for nearly 1 month. So be careful and order more spare parts. This can be a time saver. It turned out that some of the pins of the PIC32 cannot be used as outputs. This is not trivial to find out. The family datasheet alone has around 400 pages, and a pin can also have multiple functions. So it takes some time to understand the necessary parts. You will normally also find a lot of help online. In the end, I decided to take the time to use my logic analyzer to look at the signal patterns. This helped to trace down the problem very quickly. It turned out that the reset pin malfunctioned, and the display was resetted all the time. After I fixed that, the display was working without a problem. All in all, I should have used the logic analyzer in the first place. Then this video would be at least 2 minutes shorter. Next up, we try to set up the DMA controller to receive the display data from the Voyage. To make it simpler in the beginning, I'm using a serial port to transfer the received data to my computer. As told before, it is not simple to set up hardware components in such complex microcontrollers like the PIC32MX. So I was searching first for some examples. This significantly reduced the time to understand the settings. Microchip is providing a very useful API to make it easier to select the right configurations. After some time, I was getting the first data stream over the serial console from the PIC32. It looks very promising. The only problem was that the first rows of the display were missing. So I was looking again at the recorded data from the logic analyzer before, and I found out that I was just triggering at the wrong edge of the display clock. The DMA controller is now working as expected. Next, we need to stream the data directly to the new display. This was also not trivial, because the orientation of the input data was not the same as the orientation expected by the new display. After some positioning and scaling of the display data, everything looks really good. At the last step, I tried to optimize the timing a bit to get higher frame rates. But in the end, I decided that around 10 frames per second is enough for this calculator. In the last step, we put all parts back together. After removing the old display and the foam around it, it was possible to fit the microcontroller and the new display in this spot. The result looks very nice and is fully usable. I'm really happy that everything works out in the end. And I have a functioning calculator again. Now I can also use it in the night, thanks to the new display backlight. But maybe the battery life will be a little bit shorter.